Hello bachcho, let's see the question. The question says a conducting loop is kept with its center lies at the origin of a coordinate system. A magnetic field has magnetic induction B pointing along z-axis. Option A, no EMF and current will be induced in the loop if it rotates about z-axis. Option B, EMF is induced but no current flows if the loop is a fiber when it rotates about y-axis. Option C, EMF is induced and induced current flows in the loop if the loop is made up of copper and it is rotated about y-axis. Option D, if the loop moves along z-axis with a constant velocity, no current flows in it. So the key concept is effect of rotation, induced EMF and current. So for this, we will discuss all the cases A, B, C, D. This rotation axis, then change in flux. According to Faraday's law, induced EMF is E is equal to minus d phi by dt. According to Ohm's law, I is equal to E by R. If the loop rotate about z-axis, we know that z is at center. So, and we will calculate the change in flux, and we know that phi is equal to dA. It depends upon area and magnetic field. Here, magnetic field is same and area is also same. That means change in flux is 0. So, induced EMF is also 0 because it depends upon change in flux. E is 0 and current depend upon induced EMF. So, I is 0. That means option A is correct because there is no EMF and no current if it is rotate about z-axis. Now we will move to option number B. In option number B, what happens when it rotate about y-axis and the loop is a fiber. Y-axis area changes and magnetic field is same. That means change in flux is non-zero and loop is fiber. That means it is non-conducting. That means induced EMF is 0. If induced EMF is 0, then current is 0. But in option number B, it says EMF is induced, but there is no current flow. But this is wrong because if the loop is a fiber, it means it is a non-conducting. That means induced EMF is 0, but here it is induced. So this option B is wrong. Now we will move to option number C. If it is rotate about y-axis, if it is rotate about y-axis, it means area change, magnetic field same, and change in fluxes. That means if it is non-zero, if change in flux is non-zero, then induced EMF is also non-zero and current is also non-zero. That means That means EF is induced and induced current flows in the loop if the loop is made up of copper and it is rotated about y-axis. This option is correct. Now we will loop rotate about z-axis. That means same, and magnetic field is also same. That means change in flux is 0, and if change in flux is 0, that means induced EMF is 0, current is 0. That means if the loop moves along z-axis with a constant velocity, no current flows in it. This is correct. That means option A, C, D is the correct answer. So in this question, we are discussing how rotation of a loop affect the induced EMF and current. First case is if it is rotate about z-axis, the variation of flux will be 0. Therefore, no EMF is induced in the ring or the loop. So, no current flows in the loop. So, this is the correct option. Now, we will move to option number B. In this, what happens? When it rotates about y-axis, flux changes. However, there will be no EMF and no current flows. So, this option is wrong. But C, it says when the loop rotate about y-axis but magnetic field same, that means change in flux is non-zero and induced EMF is also non-zero and current is also non-zero. That means if the loop is made up of copper and it is rotated about y-axis, there is EMF is induced and current also flows. And option D says if the loop moves along z-axis, that means area is same, magnetic field is also same. It is move along z-axis, that means flux link is 0 and EMF and current will be equal to 0. So option number A, option number C, option number D is the correct answer. Hope you understood it well. Thank you.